Good morning, guys. So I just wanted to give you a little bit more direction, maybe some audio, something that it's easier to say rather than type, but a little bit more direction on your Get Salty poster. So in general, you have this Get Salty poster. You're going to use a regular piece of paper, an 8.5 by 11 piece of paper. Let me know if you guys don't have blank computer paper at home. You could totally do it on like the back of a worksheet. If you guys have any paper that's just one-sided and you just have blank paper somewhere sitting in a folder, like the back side is blank. But if you need to, you can totally do it on lined paper too. But for this Get Salty poster, you are going to be randomly picking two ions. Well, it's usually random. You guys are actually going to be choosing them rather than picking them out of a bag or a hat that I usually do in class. So you guys get to choose what ion you want to use for your cation, what ion you want to use for your anion. But the big idea here is whatever cation and anion you have, these are going to come together to make an ionic compound. And your ionic compound, like every other ionic compound, as you read about in Chapter 5, Section 2, can answer these questions. So just because you have a unique combination does not mean that your ionic compound is going to behave differently. So all you need is Chapter 5, Section 2 to answer all of these questions. I'll talk about them in just a second. But first I wanted to touch upon the cations and anions that you could use. So again, yesterday your classwork was to choose a cation and an anion. Many of you have gotten back to me about which ones you want to use. I totally don't mind if you want to make it easier on yourself or make it harder on yourself. That's up to you. But choose a cation, choose an anion, and that will be sort of your starting point for this mini project, this mini poster. If you look at the cations and the anions as well, you'll notice I'm listing elements for the top one. So I don't give you an ion. I don't give you, let's do sodium. This is a common one. You see it everywhere. So it's not like I'm giving away too many answers here. But sodium, right? This is an alkali metal. But I'm just giving you the element. I'm not giving you the ion form. The reason I'm not giving you the ion form is because you guys can tell me what it is. So that's part of the questions that are going to be in your poster, telling me what is the set charge and magnitude for your cation or your anion. Now, again, some of these might be given to you if you decide to use any of these ions on the bottom or polyatomic ions. They have charges given to you because you may not know them otherwise. But all of the things, all of the elements that don't have a charge given, let's take a look at sodium again, have a set charge. So sodium as an alkali metal has one valence electron. As you read about in Chapter 5, Section 1, when you made your own guided notes, and then more recently in our Chapter 5, Section 2 guided notes, we talked about how these main group elements, they have really predictable set charges. All alkali metals are always going to form a +1 charge. Again, because they all have one valence electron, they're going to lose it. If you lose that one negative particle and you still have equal number of protons, of positive particles, you have just one more positive proton than your total number of electrons, where they had once been equal. I hope that wasn't too wordy. Let me know if you need another example. But anyways, they have set charges, so it has to be Na+. So when you're looking at these, you're looking at the position of the element on the periodic table. Maybe you're reminding yourself how many valence electrons it has and how it has to lose those valence electrons to get a complete octet. Same thing with the anions. So we could look at chlorine, a halogen over here. So chlorine, I give you just the elemental symbol. You know chlorine has 7 valence electrons. It, like every other halogen, is going to gain 1 electron. So that's why it has that set -1 charge. So again, you're choosing whatever cation and anion you would like. And by all means, if you want to challenge yourself and use some of these polyatomic ions, feel free. It says it on the directions, but just a reminder, polyatomic ions, they stay together. So when you look at something like nitrate, NO3-1, this example right here, NO3 1-, this polyatomic ion, it's almost exactly like chlorine in that it has a -1 charge. Just because it's two atoms stuck together, don't get so hung up on it. These polyatomic ions are so prevalent and so common that we're going to end up using them almost like elements. We're going to memorize their names. They're going to be this kind of big hoopla that we'll memorize later this year. But for now, just a little bit of exposure to polyatomic ions. And again, you don't have to choose them. It's up to you which cation and which anion you choose. You just need one of each so that you're able to combine your metal and your nonmetal, your cation and your anion to make your ionic compound. So in your poster, you guys are answering all of these questions. Now I'm going to quickly scroll down to the second page here so that we can take a look at this rubric. So one thing that I have modified, I used to have appropriate use of class time for 5 points. Now I just have on time as 5 points. So the due date for this is going to be next week. So use your time wisely, but I will give you full credit as long as you're on time. Visually appealing. Now I know this might be tough for some people. I don't I don't need these to be fabulous, amazing, artistic Mona Lisa masterpieces. But if you guys need a distraction, if you like to color, if you do, like drawing, feel free, go have a little fun with this. I know some of you may not have, the best markers and stuff at your house. So I'm opening this up to 2 options. Now, I really encourage you guys to do a physical copy. I think it'll be so much easier just to write it out. But if you would like to do an electronic copy, if you would like to open up and have it be like a Google Docs, and then on Google Docs you can type it so that it's neater, you can totally do that. As far as visual aid stuff on Google Docs, maybe pull in some pictures. Maybe, like for example, in the past in class, I've had people draw salt shakers, or there's a picture about a hammer. Maybe you're drawing a hammer, or maybe it's a picture of, some flames because we talk about things being heated. So you can get really creative with it. If you guys are looking online for any other images, feel free to use them. You can, drag and drop them into a document. If you're hand writing this poster, which again, I do encourage, I think the formatting is just another layer of difficulty to put onto this. So if you do a physical copy of this, if you're writing it out, one of the things that I've changed here is I used to say, oh, it has to be in marker, it has to be in pen, no pencil. If you guys want, you can do it in pencil. Just make it look nice. Spend a little time, make it look appealing. The questions. So I want to go through these questions, but just to remind you of the point allocations, most of these, I think it's the first 8, you need to be fully correct to get your points. It's kind of just a yes or no question. There's kind of one answer. But for these bottom 2 questions about heating your salt in an oven at 450 degrees and then hitting your salt with a hammer like an impactful blow, you can get 1 point for being correct as far as your determination of what's going to happen. And then you also get 1 point for your justification. So don't forget those justifications on your posters. So again, let's take a quick look and then I'll wrap this up. As far as the points that are going to be on your poster, I don't mind how they get on your poster. If you want to do bulleted list, you can. A lot of people like to put them in creative places. I wish I could show you the examples from some previous years, but you could put them in like kind of thought bubbles. They could be anywhere around the poster. As long as this information is on your poster, you'll get credit for it. And again, a lot of this I will definitely be able to pull out of your poster. It doesn't have to be sort of question and answer. But you're telling me what are the 2 substances that make up this ionic compound? So that could be like your title. You could just like put the elements on there. What element or polyatomic ion is or acts like the metal? So of your choice, again, you chose the cation and the anion. So in the next couple questions, you'll be able to do that. But take a look at your notes. Your chapter 5, section 2 guided notes will remind you about, what do metals do? What do nonmetals do? Which are the cations? Which are the anions? Okay, so use your notes. Use everything you have at your disposal when you're answering these questions. Next couple things, what is the charge and magnitude of your cation and your anion? So for this, what I really want is, I don't want to know just is it positive or negative. I want to know, is it +1, +2, -3? That's what I mean by magnitude. In the past, I've had people just say, cations are positive and anions are negative. I need a little bit more. And again, I think I put them on the ion list, so it should list it for you, the charge, unless you're finding it yourself. But let me know if you have any questions regarding that one. Next, what is the formula of the ionic compound or salt that forms from your 2 substances? So all ionic compounds are salts. That's why we're kind of calling this the Get Salty poster. We know ionic compounds have to be neutral overall. So coincidentally, 1 atom of each may create this neutral compound, or you may need more than 1 atom. There are a few examples we looked at in our guided notes, as well as if you go back into the Chapter 5, Section 2 PDF of your textbook, you'll see a few more. But we know that it has to be neutral overall. That cation has to balance out your anion. Write the equation for this salt. So here you're telling me how they come together. So we haven't done too many equations, but I have some examples that you can mimic yours off of. So in the first example, we have the formation of sodium chloride, NaCl. So we have sodium, which is a +1 cation, chlorine, which is a -1 anion, and we'll notice that sodium, we have one atom of it, chlorine, we have one atom of it, and we see that in our chemical formula where no charge is represented, because again, it's neutral, we don't have to represent any charge. At example 2, you'll see this 2 in front of sodium. So over in example 1, they were all kind of invisible ones in front of them. So we have 2 sodiums because the charge of oxygen is 2-, so we need to balance that out. So because sodium is only +1, and we need sort of a +2 to balance out the -2 for this second example to make our neutral ionic compound, that's why we're using 2 atoms of sodium. Okay. Let's see, and moving right along here, is your ionic compound a solid, liquid, or gas at room temperature? I tell you what the degrees are in Kelvin and Celsius. You can refer to your textbook and your notes for that. What do you think would happen if your salt is heated at 450 degrees or 505 degrees Kelvin? This would be like putting a pizza in the oven. And lastly, what do you think would happen if your salt was hit with an impactful blow, like being forcefully hit with a hammer? All right, so again, if you guys have any questions, feel free to let me know. The answers to these are all in your Chapter 5, Section 2 notes. Also, if you make a rough draft, if you have your answers, or if you want me to take a look at something, send me an email with your questions. Take a picture of something you want me to review. I can approve it. I can give you a thumbs up before you start working on your final copy. All right, hope this helps.